And now I want to give you 6 very interesting matrix equations. Of course, I don't want to know the final result for variable x. I want to be sure that you know how to solve it for x. So let's go. This is our first equation, so please take a look at it, and if you want, please stop the video and try to solve it for x. We can see that variable x is in both sides, so why don't we move this term to the left in order to put them together? A times x minus x equals negative b. And thanks that matrix x is at the right side, we can take its common factor to the right. It is very important to consider that as matrix x is at the right of matrix A, we can take its common factor to the right. And we have A minus the identity matrix. Don't forget that when we are taking x common factor, we will have the identity matrix equals negative b. Okay? Now we can name A minus I. Let's say that this is matrix C, and this is what we have. C multiplying x equals negative b. Now it's time to free matrix x from its captor C, that as it is at the left side of x, we are multiplying both sides by c to the negative 1. Okay? It is very important to consider whether matrix C is at the left, as in this case, or at the right, because as you know, in this topic, there is no commutative property. And now, as usually, you know that every matrix multiplied by its inverse is the identity matrix. And the identity matrix multiplying matrix x is x. So this is the result of our matrix equation. Now we should read the statement and find matrix A and the identity matrix. In order to subtract them, this will be matrix C. We should use the old techniques to calculate its inverse. We should also calculate negative b, just changing all the positions, and then multiply both matrices. That's it. Shall we solve together this equation? Look at it. We can see that matrix x is at the left side, so we can take its common factor to the left, as in this term, matrix x is at the left. And we have x multiplying A minus the identity matrix again, don't forget it, please. And we have here B transposed times C. And we can proceed as on the previous equation. We can name these two matrices, matrix D. Please use another letter that doesn't appear on the equation. And we have matrix X multiplying D equals B transposed multiplying C. And now it's time to release matrix X from its captor, matrix D, and we are multiplying by D to the negative 1 on the right side. X multiplying D multiplying the inverse of D equals B transposed multiplying C multiplying D to the negative 1. Why? Because you already know that every matrix multiplying by its inverse is the identity matrix. And there we have the solution for this matrix equation. Now we should take a look at the statement in order to find matrix B and transpose it. Multiply it by matrix C. Then form matrix D, it's just A minus I, and inverse matrix D. And then multiply these three terms, and this would be the solution for matrix X. Let's solve together the next equation, where you can see that matrix X is at the left side, but it's surrounded by these two captors. Why don't we release matrix X from this captor first by multiplying both sides by a to the negative 1? Look, a to the negative 1 multiplying a, x, and a to the negative 1 again. And we are doing a to the negative 1 multiplying the right side. Say multiplying a to the negative 1 plus b. Don't forget the parentheses because it is very, very important. And now it's time to release matrix X from this captor. And why don't we multiply both sides by a? Look, x multiplying a to the negative 1 times a equals a to the negative 1 c a plus b multiplying a again. Why? Because, as you already know, every matrix multiplied by its inverse is the identity matrix. So here we have the solution for our matrix X. A to the negative 1 multiplying c times a to the negative 1 plus b multiplying a. And well, in order to make it as simple as possible, we can multiply matrix A to these two terms. Why? Look, x equals a to the negative 1, c multiplying a to the negative 1 multiplying a is c, isn't it? And there you have b multiplying a. So now we should look for the statement and form a to the negative 1 multiply matrix B times A, add these two matrices, and that would be the result. Let's solve together the next equation. Look, matrix X is here, and we should try to release it from these two captors. Of course, in the statement we could find matrix A, and we should transpose matrix A. And then let's multiply both sides of the equation at the left by A transposed, but inverted. You already know how to calculate the inverse of a matrix. By A transposed times X times B to the negative 1 equals to this same matrix, A transposed, but inverted, multiplying matrix C. And why? Because you know that every matrix multiplying its inverse equals the identity matrix. So what do we have at the left side? X multiplying B to the negative 1 equals A transposed but inverted, multiplying matrix C, that of course it is in the statement. And now it's time to release matrix X from the right captor, that is B to the negative 1. And what are we going to do? We are multiplying both sides of the equation by matrix B at the right, okay? And we have X multiplying B to the negative 1 multiplying B equals A transposed but inverted, multiplying matrix C, multiplying matrix B. And as usually, this will be the identity matrix, which means that we have already solved matrix X. Matrix A transposed, but then inverted, and the result multiplying matrix C, and the result multiplying matrix B. Okay? And that's it. Let's do the following equation. Well, you can see that matrix X is in these two terms. Why don't we move both of them to the left? And terms that doesn't have matrix X, we're going to move it to the right. And we have A times X minus B times X equals A squared, that is already on the right side, and we're moving to the right this expression minus B squared, okay? And take a look at this expression, because you can see that luckily matrix X is at the right side in both terms. So we can take it common factor to the right, okay? To the right. A minus B multiplying matrix X equals, and we are not moving the right side. Now, as usually, we can name this expression matrix C. And what do we have? C multiplying X equals A squared minus B squared. And we are multiplying by C to the negative 1 on both sides at the left, okay? C to the negative 1, A squared minus B squared. Why? As usually, this will be the identity matrix, and we have our matrix X solved. C to the negative 1 multiplying A squared minus B squared. We should read the statement to find matrices A and B in order to form matrix C, and then invert it. Then we are calculating A squared, B squared, and subtract them, and finally make this product. That's it. And finally, the last equation, you can see that it's quite similar to the previous one, but there is a very big little difference. Look, let's move to the left side both terms that are in X. A times X minus X multiplying B equals A squared, that is already on the right side, minus B squared. Now it's time to consider where are we going to take X common factor. But you can see that matrix X is here at the right side of the term, and here is at the left side of the term. So I'm afraid that on this occasion we cannot take matrix X common factor neither to the left nor to the right. So what are we going to do on this occasion? Well, I'm afraid that there is no other way out than creating a template for matrix X. That is A, B, C, D, and insert this template into the equation, the first one, for example, operate and try to proceed as on this other video where we had to use the same solution. And now watch a theory video if you think you've gotten lost in some aspects, or skip to the next exercise to continue climbing. And as always, like, turn on notifications and comment. See you soon!